Now let's look at a geometric sequence. So in a geometric sequence, the ratio between two consecutive terms is constant. So now, for us to say this sequence is a geometric sequence, we will have to check if ever the ratio between two consecutive terms is constant. Remember, we said consecutive terms are what? Are terms that are close to each other. So now when I use the terminology consecutive terms, I hope now you understand what I'm talking about. From the previous video of arithmetic sequences, I already explained what is a consecutive term. So let's say, for example, this is term 1, this is term 2, this is term 3. So now, the consecutive terms here will be what? Will be term 1 and term 2. These are consecutive terms, and also term 2 and term 3 will be consecutive terms. So now, if ever the ratio between these consecutive terms is the same as the ratio of this consecutive term, then the sequence is a geometric sequence. Let's check the ratio between term number 2 and term number 1. If is equal to the ratio between term number 3 and term number 2. What is the value of term number 2? Term number 2 is 6, and the value of term number 1 is 3. Equated to what? To the value of term number 3, which is 12, divided by term number 2, which is 6. So now 6 divided by 3 will be equal to 2, and also here 12 divided by 6 will be equals to 2. Now we can see now the ratio between two consecutive terms is equal, is actually constant. We can conclude to say now we have a what? A geometric sequence. So this ratio that is constant is represented by R. So the value of R will be what? Will be the ratio that is constant. So in this case, we have the ratio as 2. And then A will always represent the value of the first term in a geometric or an arithmetic sequence. Remember, for quadratic sequence, A is another story. So same as in arithmetic sequence, we also have a general equation that will help us to find, let's say, for example, a value of a term that is far away, or for example, a position of a term, of a value of a term that is far away. So the general formula or the general equation is given by Tn is equals to A multiplied by R, which is the ratio, and N subtract 1. So be careful here, because it's only R that is raised to the power of N minus 1. A is a coefficient of R, of which R is raised to the power of N minus 1. So now if you have to find a general equation or a general formula for this sequence, you have to substitute the value of what? The value of A and R. So now Tn will be equal to what? To 2 multiplied by 3, all raised to the power of minus 1. So be careful here. You can't say 2 multiplied by 3, because now 3 has an exponent of n minus 1. That means you can't multiply this basis. I don't know if I have told you that you can only multiply the basis if ever you have the same exponent. But in this case, we don't have the same exponent. Therefore, we can multiply the basis. And then you also remember the other law. If ever the basis are if you multiply the same base, you add the exponent. But when we move forward, you will see what I'm talking about. So for this sequence now, this is our general formula that we can use to determine any value in the sequence. So let's not waste any time and look at these following questions. So the first question says what? Determine the number of terms in a sequence 2:4:8, and then the last term is what? Is 1024. So be aware, you see now, they say determine the number of terms in the sequence. They did not specify which sequence is this. So the first thing that you do, you will have to identify which sequence is this. Is it an arithmetic sequence or is it a geometric sequence? Let me just write this sequence here. It's 2:4, 8, moving forward all to 1024. So we know 2 is the first term of the sequence, 4 is the second term, and then now 8 is the third term. So basically, what I will advise you to do, every time when you are given a sequence, it did not specify that this sequence is a geometric sequence or an arithmetic sequence. You will first have to check if ever this sequence is a arithmetic sequence, because it's easy to do that. You will just say what? Term number 2 subtract term number 1, which will be 4 subtract 2, which is how much? Which is 2. And then you will say 8 subtract 4, which is gonna be what? Which is gonna be 4. So now we can see that the difference between two consecutive terms is not constant. Therefore, this sequence is not an arithmetic sequence. After you have seen now this sequence is not an arithmetic sequence, then you can check if ever this sequence is a geometric sequence. So remember, to check if a sequence is a geometric sequence, you use this formula to say term number 2 divided by term number 1 is equal to term number 3 divided by term number 2. So if this condition is correct, therefore the sequence is a what? Is a geometric sequence. So term number 2 has a value of how much? Has a value of 4, all divided by term number 1, which has a value of 2. And then term number 3 has a value of 8, all divided by term number 2, which has a value of 4. 4 divided by 2 is going to be equals to 2. And now 8 divided by 4 is going to be equals to 2. Therefore, we can conclude to say now, this is a what? This is a geometric sequence. So now we know what type of a sequence is this. We can apply the general formula for that type of sequence. In this case, we now know this is the what? This is a geometric sequence. Therefore, the formula for geometric sequence is Tn is equal to A, which represents the first term, multiplied by R raised to the power of n minus 1. So remember now, we found our constant ratio to be equal to 2. You can also do the same by doing what? On your calculator to just check to say term 2 divided by term 1, and then you just write it here. 4 divided by 2 is going to be 2. And then you also say 8 divided by 4, then it's going to be 2. So now you will know now you have what? A constant ratio, because you have divided between two consecutive terms. Okay, so now remember A represents what? The value of the first term. So when we substitute in our equation, the value of A will be equal to 2. And now the value of R is what? Is 2, because we have calculated it, or we have proven to say the ratio is constant between two consecutive terms. Okay, so now when we simplify this further, to see now on your right hand side, you have what? You have a product of numbers that have the same base. So remember that law that says when you multiply the same base, you add the exponent. And therefore you will say now you keep the base the same and then you add the exponent. This first term has an exponent of 1, so it's going to be 1 plus n minus 1. of which 1 minus 1 is going to be 0. I can just erase this one here and this one here, sorry there, and then my answer will be what? Will be 2 to the power of n. So this will be the general term of the sequence. So now we have the general term of the sequence. Remember, if we have the general equation actually, we can find or solve so many problems that will be given to us. So the problem here, they say we must determine the number of terms in the sequence, but they have given us the value of the last term, which is going to be how much? 1024. So if we have this value of the last term, we know the value of the last term will be equal to what? Tn, and therefore we find the value of n, which will give us the number of terms in the sequence, because it will be at the last position of the sequence. So now we're gonna say what? We're gonna say 1024 equal to 2 to the power of n. And then we have to simplify and find the value of n. So I'm going to introduce a new topic to you, or maybe your teacher have already did it with you in class. So we're going to apply what we call a log function. So let me just make an example first before we can apply the log function on this equation of ours. Let's say we have now 3 raised to the power of n. So if we apply a log function here to 3, we say log function of 3 to the power of n. So basically, an exponent will become the coefficient of the log function. So that means now the answer will be what? Will be n log of 3. I hope it makes sense. Let's do it again on the original equation so that it can make sense to you. Okay, let me just erase this one. So I'm saying to you now, you have to apply what? If you ever you have an exponent as a variable or whatever stuff, and then you want to find that variable, you will have to apply what you call a log function, because a log function can actually drop an exponent to be what? To be a coefficient of it. So you apply a log function on your left. Remember, what you do on your left, you also do on your right. And then you also apply a log function on your right. So it's going to be a log function of 2 to the power of n. This one on your left here, you will just keep it as it is. It's log of what? Log of 1024. And therefore, here, because we have an exponent of n, this n will become what? Will become a coefficient of log. And then whatever that is inside will remain the way it is. So now we'll have what? We'll have n log of 2. So when we are here, we can basically just cancel the log of 2 so that we can be left with what? With n. Then we divide by the log of 2 on the other side. Then you just punch everything in your calculator, because this one will cancel out. And therefore, the value of n will be equal to 10. The value of n is equals to 10. That means the number of terms will be 10 terms, because remember 1024 is the last term of the sequence, and then it's located at position number 10. That means the number of terms will be how much? Will be 10 terms. Okay. So now let's look at number C. So number C says that if 5 is to x is to 45 are the first three terms of a geometric sequence. Determine the value of x. Okay, so now in this question, they have given us, or they have told us now, this sequence is a geometric sequence. So we don't have to check if ever is a geometric or it's an arithmetic, because it is given to us to say now this sequence is a geometric sequence. Therefore, if this is the case, then we know what? We know term 2 divided by term 1 will be equal to what? To term 3 divided by term 2. Okay, so what is the value of term number 2? Term 2 is x, and term 1 is going to be what? It's going to be 5. And then term 3 is going to be 45. And term 2 is going to be x. So basically here, we're just going to cross multiply. When you cross multiply, you're going to say x multiplied by x is going to be x squared. And now when you say 5 multiplied by 45 is going to be 225. 225. Then remove the square of x by introducing the square root. Remember, every time when you introduce your square root, the answer can either be positive or negative. So the value of x will either be plus or minus 50. Okay. So the value of x can either be positive or negative. Yeah, because you can have a ratio that is negative and you can also have a ratio that is positive. So basically, we don't know which value is valid or which one is unvalid. But for this case, both the values are valid. If ever they have given us to say the next term, of which is going to be the fourth term, and then the fourth term is a positive number, therefore we will say now the value of x will only be positive 15. But in this case, we don't know if ever the value of the fourth term will be negative or positive. Therefore, the value of x can either be negative 15 or positive 15. So now let's look at the last question. Okay. So the last question says what? Determine the geometric sequence whose 8th term is 9 and whose 9th term is 25. So basically, in this case, they have given us two terms. And then remember, they have also told us the condition here to say this sequence is a what? Is a geometric sequence. Okay, let me just underline here to say now this is a what? This is a geometric sequence. So they have given us, let's just write the data that we have. They say term number 8 has a value of 9. And then now term number 10 has a value of 25. So when they have given us the statement to say now, this is a what? A geometric sequence. What do we know about the geometric sequence? Remember, we know that if a sequence is a geometric sequence, a ratio between two consecutive terms is what? Is constant, is equal. So now they have given us what? Term number 8. They have given us the value of term number 8, but we don't know the value of term number 9. They have also given us the value of term number 10. So we can say now the term number 8 is going to be how much? It's going to be 9. And then the value of term number 9 we don't know, we can say is x. And therefore we can say what? We can say the value of term number 10 is how much? Is 25. And therefore, when we have this, remember on the previous question, if you have 3 consecutive terms, you can actually find the middle term, which is term number 9. So let's try to find term number 9. To find that, we'll say what? We'll say term number 9 divided by term number 8. Remember, consecutive terms. The ratio between consecutive terms must be constant. It will be equals to what? To term number 10 divided by term number 9. We know this statement is correct because we have given the condition that this sequence is the geometric sequence. Therefore, now we'll substitute the value of what? Of term number 9, which is x, and also substitute the value of term number 8, which is 9, and also substitute the value of term number 10, which is 25, and substitute the value of term number 9, which is x. And therefore, we do the same thing, we cross multiply. When we cross multiply, it's going to be what? It's going to be x squared is equals to what? 9 multiplied by 25. 9 multiplied by 25 is going to still be 225. 225. So we apply the square root. Remember, when you apply the square root, the answer can either be positive or negative. And therefore now the value of x will be what? Will be plus or minus 50. Okay. So now the question says what? We must just determine the geometric sequence whose ratio is 8 term and on who has the 8th term being equals to 9 and who has the 10th term being equals to 25. So we can now find what? We can find the general term. If we have the general term, we actually have the ratio. So now remember, the equation of the general term of what? Of a arithmetic sequence is what? Is Tn. Tn is equals to a r to the power of n minus 1. So in this case, we don't have the value of the first term. Yeah? But we can find what? We can find the value of r. Let's assume or make a conclusion to say now the value of x is actually positive 15. Okay, let me just erase this side. Let's assume to say now the value of x is what? Is positive 15. And therefore, we're going to have what? We're going to have term number 8 being 9. Then this is to 15. And is to 25. So basically, because we know this is a geometric sequence, we can just say r, it will be equals to what? It will be either term number 9 divided by term number 8, or you can say term number 10 divided by term number 9. The value of r will be equals to now 15 divided by 9, or 25 divided by 50. Value of r will be how much? Let me check. 15 divided by 9 is going to give us how much? 5/3, of which is going to be the same as 25 divided by 50. So now we know the value of r, but we don't know the value of a. What do we also have? We also have what? The position of what? Of the 8th term and its value. Then we can find what? The value of a. So we know the value of r. We can say now we know the value of n, which is going to be 8. If n is 8, therefore Tn will be equals to 9. Therefore, the only unknown here will be a. There, in this case, we'll be able to calculate the value of a. So let's substitute here to say now the 8th term will have the value of 9, but we don't know what is the first term, which is a. All multiplied by r, which has a value of how much? Of 5, all divided by 3. All to the power of what? We know now the value of n, because 9 is at position number 8, is going to be 8 subtract 1. So we're going to have 9, which is equals to Let me just put this in the calculator to say it's 5 divided by 3 all raised to the power of 8 minus 1, which is going to be 35, comma 72a. Then when you divide both sides by 35, comma 72, 35, comma 72. Therefore, we will get the value of the first term, which is a, being, let's say 9 divided by the answer. It's going to be what? It's going to be 0, 2, 5, 2. So now this is the value of a. Then we can conclude to say now, okay, so the general formula for this sequence will be what? Will be Tn equals to a r to the power of n minus 1, of which we know the value of a now is equals to how much? Is 0, 2, 5, 2, and then the value of r is going to be how much? It's going to be 5 over 3 all raised to the power of n minus 1. Okay, so now with this equation of ours, our general solution, we are able to determine the value of any term. Let's say now our sequence, term number 8 that we have is going to be how much? Is 9. And then we said term number 9 is positive 15. We concluded to say now it's positive 15. And then we have term number 25. So basically with this general equation, we can find the value of each term here. Let's try to check if ever the value of term number 10 is going to be 25. Let me just put that on the calculator. 0.252 all to the power of 5 divided by 3 raised to the power of 10 subtract 1. So the answer is actually 25,005. Yeah, that means now the equation is correct because I just rounded off this one. Okay, thank you very much, good people. The lesson for today will end here.